Hello and welcome to our presentation on how to contain costs without impacting time for innovation. My name is Stephen Miller and I'll be moderating today's session. Shortly, I'd like to welcome my EMEA colleague, Dave McDermott.
Okay, so welcome to this session on industrial machinery. This is all about how we contain costs, but without costing us the really important things to our business, innovation. There are so many things going on out there in the world today that it kind of boils down to a few really simple things that are a constant challenge for our industry. So first of all, what is going on out there? This picture here says it all for me. This is a game of chess in the world, and every piece is a different part of the world. So there are many factors affecting what's going to happen next. And every country and every zone is planning their strategies based on what they see. There are challenges around global pandemics, the economy, the political situation in various countries. And this is creating disruption and the inability to predict what's going on in the future. So every organization is thinking, how do I plan the next move? What can I anticipate? And we're going to look at how a priori can help us do that as well as possible. So when we talk about our industry, which industry do we particularly mean? So for this session, we're grouping together many industries that have a bit of a common denominator. If we try to understand where the challenges are and what's going on, we could perhaps look at a matrix of, say, the global trends, the major mega trends that are impacting each of these sectors in different ways. If you look, for example, at, say, sustainability and social dynamics, these are an impact on, say, agriculture and construction. So for sustainability, the world is building huge civil engineering projects to either build its way out of economic depression because of global pandemic, or because we have to find greener, cleaner ways of producing power. Unfortunately, for the oil and gas industry, it's a double whammy. The sustainability issue means we're using less fossil fuels, but of course, the latest pandemic means that aircraft are spending more time on the apron than they're doing in the sky. The demand for fuel is dropping, and as we've all seen, the oil prices dropped dramatically very recently as a result of this. But of course, these industries, especially oil and gas, are thinking about ways in which they can generate products that are affordable, so they can win more bids, and that still adopt the principles of clean, green energy, perhaps diversification. They all come down to one big issue, which is about how do we innovate our way out of that life cycle. In fact, we could boil all these mega trends down to a handful of really important things for each of these sectors. The main one being innovation. In the semiconductor manufacturing world, of course, innovation is a constant challenge. It's an annual challenge. Moore's law, which is a self-fulfilling prophecy, dictates that they have to bring out next generation machines all the time. In the machines that manufacture for us, the fourth industrial revolution, the Internet of Things, and customers changing business profiles mean that the machines need to be smarter. And that means that regardless of what kind of equipment we're creating, we need to invent new things, new systems, new controls, new parts. And that means uncertainty and new things. Uncertainty in how the design is going to operate, of course, but have we procured these things before? At what cost? What's the best way to do this? Have we used the supply chains that we've used before? Because we're bringing in these new parts. So innovation creates a new challenge for every one of these sectors and is driven by the fact that the world is changing. We have to innovate. Closely coupled with that, of course, is shorter product life cycles. With increased innovation comes shorter product life cycles. They don't stay out in the market for so long, or the next generation comes along a lot quicker. And that puts large pressure on the product development organization to get the product ready for market much quicker. This isn't a new challenge. In fact, none of these challenges are new. They've been going on for years, but the focus is becoming more and more on a lot of organizations. Companies are adopting new business models. Power by the hour is the most classic one, where you sell your product by a service, not the product itself. So for the OEMs, that creates another new challenge. We now become the customer of our own products. Being a customer, we want value for money. cost starts to become a bigger issue for us because we're the ones that are buying the machines that we make. And of course, we're going to service and maintain those machines. And therefore, we don't want to be paying too much money for the new parts and equipment we need to service and maintain them. And cost is at the heart of driving these new business models. We've got to do them affordably. The supply chain, as we've all seen in recent times, is just shifting it for all sorts of different reasons. Even just the political situation across the world means that the relationship between two large countries, as that changes, the costs and the supply bases have to shift as well. And what we've seen recently, certainly in a priori, is that customers of ours are having to shift their supply chain strategy and need a lot of insight to be able to do that. And a priori clearly helps them with that. But the biggest challenge for all these industries, even if they could address all that stuff in blue there, is that they're going to have to do it and focus on the fact that they have low volume products, relatively low volume, especially compared to automotive, but with high part counts. Some of these machines have tens of thousands of parts in them, and we're only selling them in low volumes. So if we're trying to address the cost focus while we're trying to innovate, we're trying to work with shifting sands here. It becomes very difficult to find where in here is the needle in the haystack. Where is the part that I'm looking for that's costing me money? How can I find a better way of getting all these components supplied to make it cost effective for me? How can I get them quickly and so on? So an organization thinking about, well, where can I save money? Hopefully they're trying to ask that very question during the product development phase, not once they've gone into production, because that's where they can have the biggest impact, of course. The traditional approach is to take a machine like this and look at the obvious targets, the big heavy castings, the most expensive components, the long lead time items. Just focus on them because that's all we have the time to do, quite frankly, and identify what the cost should be, what the cost saving opportunities, and do something about that in a timely fashion. Once we identify what the costs are, once we identify what we can do about it, we are then going to climb a mountain to get that done. So all those parts represent all the effort of our business to climb that mountain, identify the cost, do something about it, and get our product to market cost effectively. But that mountain isn't a mountain. It's actually the tip of a very large iceberg. And what lies beneath it are all the hidden costs, the hidden uncertainty, the things we don't know about until it's too late, until we get to production and we're not as competitive as we thought we're going to be. Our first machines are going to be run at a loss, or we're going to have a compromised time to market because we're trying to do something about that in the meantime. In this iceberg, below the waves, are thousands of components that we've not had the time to look at, or even if we did, we don't have the time to do something about it because we don't have the insight. Imagine if we took all those components now, not just the ones that we traditionally looked at, the yellow ones. Let's look at the blue ones as well. It looks like everything. Then we now have the opportunity to look at our entire product definition and plot on a graph of, let's say, should cost versus the cost drivers for a process group. Like in casting, the weight of a component could be a cost driver. Then we can identify the trend and then pick out the outliers. Now, this is a really interesting area because if you do this with a few hundred components, you're not only going to identify just a few outliers, but the relative information of those outliers is going to be diluted. The more that we can cost, the more exponentially valuable these outliers can mean to us. Now, the obvious ones are these red ones up the top here. These are parts which are more expensive than they need to be because of something about the design that's made it more expensive against its cost driver. These are the traditional targets for value engineering and looking for design issues. And if we found those early enough on, we can do something about them. But here's the other interesting thing we can find if we have a big enough data set to look at, and that is the ones which are good. These components here are good for manufacturability. There's something about the way we've designed those that we should do more of. And we can start to implement procedures in our business to say, do more of this, do less of that. And clearly, a priori helps with it. So by able to look at the entire product and understanding where the cost challenge is going to be from a design for manufacturability perspective, we are able to identify the real money-saving opportunities. And we're going to do this not at the expense of innovation. We're still going to carry on designing world-class products while we do that. Now, let's take all that information again and let's scatter on a different plot. A classic plot here of should cost versus quoted cost or actual cost. Again, the ones up the middle, the 45-degree line, is where we're getting the same should cost and quoted cost. That's good. However, the outliers tell us something else. Now, the ones above the line, these are the ones where we're getting perhaps not the best deal from our supplier for all sorts of different reasons. But these are opportunities for collaboration. These are ones we could sit down with the supplier to talk about, because there may be something about the way they're making it that isn't quite optimal. And again, by looking at all the components in our product, we can more easily find the ones that really stand out, the real opportunities to work with suppliers on getting a good price that's good for both our businesses. Now, if you were in the Alstom session yesterday, you would have heard that Alstom and their suppliers are working towards getting a fair price for their components very quickly, because it's good for both their businesses. If that supplier survives, it means Alstom can carry on producing trains. That's what they've got to do. If they can't produce trains, they're out of business. The supplier gets a price that's affordable for them to run their business. And the existence of that supplier, in fact, the success of that supplier is key to the success of Alstom. Symbiotic relationship that relies on the ability to identify this and then do something about it and work towards it. The other really interesting area is the outliers down here. These are components where we're getting a really good price compared to the should cost. There's something about those parts that is driving the cost down in the supply chain. Now, it could be one of two major things. It could be that the supplier just wants to get our business because they want to win the contracts and do more with us. That's good. We want to do more with that supplier. So it's going to help them. It's going to help us. We'll get a good price. It could also be because our supplier, for some of these components, has a really efficient process that means it's cost effective. We need to give them more parts of a similar type. And through data analytics, we can start to understand where these components are and which ones to go and do something about. So in our industry, where we have thousands of components, if we can get to all the ones below the tip of the iceberg, we can start to do much better things for our business. So let me show you in a priori how we start to do some of this. The first thing that you would have seen a lot of from the various presenters from a priori is the fact that we're using the cloud. And the cloud creates an opportunity for this industry because there are so many stakeholders involved, and there are so many remote locations, especially in today's economic and global environment, that we need to work much more remotely and get access to data very quickly. Now, let's assume just for now that a priori is doing all the manufacturing simulation in the background. And doing that manufacturing simulation means we have a database full of good information. Now we can start to use it to make better decisions around cost. So the first thing we can do is do those kind of outlier reports. Here's a list of parts along the bottom here from left to right. And for each part, we can see what the quoted cost is. We've read this in from ERP. And a priori for each of those components also generates a should cost through manufacturing simulation. And the red dot represents a potential saving. So this component here, we're potentially going to spend $110,000 more than perhaps we should do for all sorts of reasons. However, if you look at the difference by percentage, then the difference between the should cost and the actual cost is actually quite low. It's only 4.4%. This component, however, has a 21% difference. There's something about that component with a supplier that we need to have a conversation with. And it's perhaps just we've got the wrong part and the wrong process. Maybe they've only got 5 axis machines and we would be better off on 3. And the saving potential is $37,000. So this is one that we want to have a good conversation with our supplier about. So again, using the ability to cost lots of things and simulate manufacture gives us the ability to identify these much earlier on in the process. Now, this principle has been going around for quite a long time, but bear in mind, we've got hundreds of thousands of these to consider. So we need to find the real needle in the haystack to get to this point to do this kind of analysis. And then when we start to dig into it, we find that this component here, this is the one that we want to go and talk to the supplier about. This is only one component out of thousands. We might not actually buy that as one component. We may buy it in a bid package or a work package. We may buy it as part of an entire assembly from a supplier who's going to build the whole thing that bracket fits into. So we have a slightly different challenge now. When we think about the things that we want to procure, we will take that package of 50, 100, 1,000 components and run them through manufacturing simulation to understand the cost at every part of the world. So if I have a problem with supply in one part of the world and I need to look for another, I need to cost not just one component in 79 regions around the world, I need to cost tens of thousands. And therefore we need the power of a priori and a priori in the cloud to do all that mathematics, to plow through it and tell me that if I go to India, I'm going to pay $53 for my work package. But if I go over to Switzerland, it's considerably different at $340, a huge difference. On the fact that we work in a dynamic supply chain environment, I can start to decide about a multi-source strategy that uses a bit of low-cost region, a bit of high-cost region for stability. And as the geopolitical situation changes, then I can start to understand the impact over here. If logistics costs I do want to shift my focus from one manufacturing region to another, especially when I've got buckets of parts I need to deal with. I need to start to understand the impact of shifting from one place to another on a diverse set of components. So here is a graph of components along the bottom here, and I'm looking at the cost of these components in, say, Mexico versus China. And then the red dot represents a saving between the two. The components on the left-hand side are more cost-effective to be manufactured in Mexico. So when I define my work package, I'm going to put all these components into Mexico, today anyway. These components over here are more cost-effective in China, so I've got them made over in China. The ones in the middle are sort of cost-neutral. They're about the same in both regions for all sorts of different reasons. In those, I can decide where the best place to put them is. Perhaps if I have a new supplier in Mexico, I might want to give them all these middle parts as well so I can get the volume of supply. I can get more buying power by putting them all over into that region. Again, I'm just looking at a subset of a few components here, but when it comes to looking at tens of thousands, then this is something we can't do with an Excel spreadsheet. We need the power of the web to help us do it. Now, when I create a bid package, inside that manufacturing simulation is the information that tells me what the cycle times are for the different pieces of equipment that are creating them. This work package here that I've analyzed is telling me I need nearly 9,000 hours of 5-axis machining. So if I'm making this internally, I factor that into my capacity planning. If I'm putting this out to bid, I'm going to tell my supplier potentials that this is the kind of capacity requirement that you will need to produce this work package. This helps the supplier decide how they're going to bid against it, and it really helps me because I'm going to get a supplier that is well informed, that can make decisions instantly about whether they bid for this or not. Because if there's any trouble later on with having to get parts made in another facility, there may be delays, quality issues, cost issues, the list could go on. I want to pick the best supplier. I'm going to help my supplier do that. And I apply the same principle to materials as well. So for a particular work package, this is all the material requirements I need. I need this amount of aluminium of that particular grade. Same with plastics and metals. These are all the different quantities I need. So if I give this to my supplier and say, to fulfill this bid, you need to have all this material. Can you get it cost effectively? Do you have good bargaining power for aluminium, for example? and therefore give them the insight they need to help them decide how they bid for this package of work. And I get myself a good supplier. This also allows me to help with my own internal design, my own innovation challenge. If I know what materials are good prices and I know how much of my product is using it, I can understand the impact on cost. Perhaps I could redesign to use a slightly different material strategy when I know how much I'm using. And finally, let's look at those cost outliers. Again, I'm just looking at a handful of components here, but we could look at thousands. Now, this is a plot of weight versus cost for cast components. And the components above the line are slightly more expensive than they should be. The size of these bubbles represents the spend on these components, and the color of the bubble represents manufacturability. In other words, large orange or purple bubbles towards the top of this line are opportunities for cost reduction through design. So as part of my innovation challenge, I'm going to be creating new parts and equipment that I haven't done before. And I need to understand if I'm creating myself a cost challenge, and this is a component that is part of my cost challenge. And a priori will take me to that component and tell me what it's all about. And then for that component, I can explore the manufacturing simulation that a priori did behind it to tell me why it's a manufacturing outlier, why it's a design outlier, what the manufacturability issues are, and what I could do about them. So a priori's ability to cost thousands of components in the background is kind of key. But how do we get to that point? For most of you out there, you've seen that a priori does bulk costing. And the ability to bulk cost means we can cost thousands of components in the background. But we need to make that part of our business process. And that's why a priori is focusing on Cost Insight Generate that you would have heard about in this conference. And Cost Insight Generate takes the design data as soon as it is created from PLM and simulates the manufacturing process on it. And from that, we get the information about manufacturability and where it lies in an outlier diagram for design or procurement. And it provides reports to the key people in the business so they can do something about it in a timely fashion. So we understand the challenges of this industry, the fact that we have thousands of components to deal with, the pressures on the organization of innovation and time to market means that we've got to do something a bit smarter. And we're helping that with a priori. So my question to you is, looking at your own internal organization, what lies beneath the tip of the iceberg for you? Where are the challenges that you're facing and how are you going to go about addressing them? And that's how a priori is going to help us focus on cost, but without diverting our valuable resources so we can make sure we out-innovate our competitors and stay competitive in the market. Okay, so I hope that's been useful. Steve, are there any questions out there?
Thanks, Dave. Yeah, we have some questions. The first one is around cost of non-quality. So it's from Mark, and the question is, where does quality score come into the cost comparisons? As you know, the number of non-conformance dispositions or concessions add to both tangible and intangible costs. Are these data included in actual costs prior to comparison with the should costing?
Absolutely. Yeah. So for those of you who know a priori, when it does a manufacturing simulation, one of the elements it uses to calculate is yield. And yield is driven around various aspects of quality and non-conformance. Now, we can work with assumed yield rates that we can leverage from different process types, or once we know a particular yield that we work with, we can factor that into the equation. So it can be part of it. And the more insight we have into that, the more accurate and precise our simulation is going to be. When we don't know that, we can still use the outlier reports to identify if there is a place where non-conformity is going to cause us problems. And if we're too close to the cost challenge on something and we think there might be a quality issue, then that's an area of focus for design, quality, manufacturing, and procurement as well. And I think, does that answer the question, Steve, do you think?
I think so. So we've got another question then from Daniel. which is how do you handle a diverse supply chain with varied manufacturing capabilities when it comes to creating should cost models?
All right. Good question. So a priori could simulate as many different virtual factories as you wish, as perhaps you know, Daniel. Those factories can have lots of different equipments in them, different process routings. So a priori can simulate every possible option that you could consider, and you can then go in and define your own. Now, when it does a simulation, by default, it's going to look for the best case. It's going to look for the best use case. In reality, a particular manufacturer will do something slightly different. So first of all, we can create the digital factories to represent each different type of manufacturer and have a priori cost one component every single one of those to find the best manufacturing opportunity for us. But we can also use the outlier reports as well, because we don't know what we don't know until we've done the simulation and the analysis. So perhaps we can use the outliers to identify where the ones which are really sensitive to that are, and then re-simulate those in the different supply options to understand what the impact is going to be. It's a very complicated equation, I'm sure you appreciate. And through analytics, we can help find the right things to focus on, in my view.
Thanks,
Steve?
Dave. Well, we're approaching the end of our allotted time. So just like to say thank you, Dave, for the insightful presentation.
Thanks very much, everybody. I'll